Welcome to Corda. Corda, as you know, is a platform for building your own blockchain or distributed ledger applications. Before we dive in, I wanted to touch on why we believe that Corda exists and why it's a fantastic solution for many of the real-world kind of problems you might be facing. So Corda was started by someone called Mike Hearn. He's got the first commit in the repository. I worked with Mike Hearn way back in the day at Google for a little while, and after that, he was one of the core engineers on Bitcoin. So he worked on a lot of the foundational stuff that happened there. There's a lot of wonderful stories where at some point Satoshi gave him 20,000 Bitcoin and he returned it saying, I don't know what to do with this, you can keep it. Which by today's evaluation would have been a sizable chunk of money. Despite that, he is still fantastically optimistic about life, so that's good, right? But so his experience with Bitcoin was twofold. On the one hand, he was incredibly excited about the potential that a decentralized currency could bring to the planet. But on the other hand, he had some frustrations with the shortcomings of what restrictions existed in the Bitcoin space. And one of those restrictions was that it didn't necessarily fit with the kind of use cases that the businesses that exist today would see. And he felt like if we can take anything that involves a contract between institutions and people and put that on a distributed ledger, we could change the way that business is done in this planet. So he looks at a few of the shortcomings, and one of them is, of course, is identity. The Bitcoin and Ethereum, there's a pseudo-anonymous identity that doesn't really give you the trust of who you're doing business with. So that's if you're doing business between banks or at a stock exchange, logistics company, anything else, then you kind of need to know a strong identity of the person you're dealing with. Likewise, privacy doesn't exist because the way that a globally distributed ledger works is that everyone gets a copy of every transaction. That's the very thing that makes Bitcoin work, right? The other downside of that is because it is globally distributed, you need something to prevent attacks on the network. And that's where proof of work and clumping together transactions into blocks, which is part of the name blockchain, have to be in place to prevent Sybil attacks, double spend attacks, and all the other kind of abuses on these kind of networks, right? That has the downside that a transaction can be quite lengthy, not just processing intensive, but lengthy in time as well, even up to 7 minutes. Now, when you're doing transactions where seconds or even milliseconds matter in the finance world or those kind of situations, then that's not acceptable, right? Speed is a critical factor there. And finally, when you're coding in Solidity or any of these other languages, it's hard to integrate that into your backend system. Say that your organization is driven by Salesforce or an inventory system or a system that keeps track of a stock market. It is really hard to integrate those kind of transactions on a public blockchain into those backend systems. So those were some of the limitations where we felt that if we could overcome those, then we could take blockchain or DLT, the stuff that powers anything from Bitcoin and Ethereum, and change the way business is run and make that a lot faster, more cost effective, and instill a lot of trust in what is usually a trustless environment. Finally, his vision was also like, if you look at things like banks, they suffer from the irreliability of paper contracts. For instance, if you look at banks, that they have this huge team that at the end of a period takes all the transactions, compares notes with other institutions and say, well, we have a slight disagreement of what the stock price was at that time or the percentage on the dividend. And they have to do the math on that. It is a huge exercise, a lot of expenditure. And then finally they say, well, you owe me that much money. I owe those other guys that much money. And then finally you reach a consensus. If you have a shared understanding on a distributed ledger, none of those things are needed anymore. So those are the things that went into the beginning of what made Corda. A strong consensus shared between multiple distrusting nodes, a strong drive for privacy so that not every transaction is visible to everyone, integration with backend systems using any JVM kind of language, a strong identity which guarantees that the person you're transacting with is the person they say that they are, speed that is measured in milliseconds, and finally, it is open source. And it also allows you to build your own networks if you don't want to use any of the stuff that we've provided. So it gives you full freedom to build a very opinionated DLT implementation that works for your specific business needs. The final thing that Mike said is that it would help tremendously if code sharing would become a thing between institutions and people. Like right now, anytime that you have to connect systems to each other, everyone has to implement their own version of it, try to speak the same protocol, and you have to repeat that for every organization that connects with each other, which is prohibitively expensive and also, again, leads to the potential for many mistakes and different interpretations of the rules. So he said, wouldn't it be cool if you could build one DLT app and share that code with all the people that are connected to your network and are engaged in that protocol? And he said, I believe that if you build a Corda app, which is our version of the distributed application, you should have 3 people spend 3 days and have a working solution for any kind of business problem you're trying to solve. And that's powerful, but I think we pulled it off. If you download Corda and you install that, you only have to implement a couple of classes and you have a fully up and running functional system. Everything else, cryptography, identity, connecting, network fault tolerance, everything else that is a part of building these kind of solutions is part of the toolkit already, and you never even have to think about it. So I figured it'd be good to kind of give you guys a sense of how it works. And generally speaking, we always use party A and party B, or Bob and Alice, which gets a little bit boring, so I figured I'd use a Looney Tunes network instead to introduce a bit of fun. So imagine you have a Looney Tunes network, you have all these different characters, and they want to be able to transact with each other and be able to buy gizmos from Acme Corporation, right? Finally, there's the notary pool, and the notary pool is the thing that allows you not to have blocks or proof of work in your network. Anytime that a transaction happens, both parties sign it. That transaction is then sent to a notary pool who checks on double spend, Sybil attacks, and all the other possible ways in which a network could be abused. And if that checks out, it adds its signature, and that's the moment at which a transaction is final, and it is committed to all the parties that are involved in that transaction. So say that Willy Coyote wants to buy a catapult. We all know this is going to go wrong in the end, but still he needs one for the next episode, right? So he sends it a request to Acme Corporation, and Acme Corporation sends something back which we call a state. Now, a state is like a database record or an object that represents the transaction you're doing. And in fact, that state is what is chained together to make the chain for whatever entity you're selling. Now, one of the things that is different about Corda versus the networks you might be familiar with is that every type of digital asset has its own chain. So at some point, Acme Corporation built a whole bunch of catapults, and then they issued a block which said, hey, we now have 1,000 or 2,000 catapults, and every time a transaction happens, that is appended to that chain. So there's a chain for catapults at Acme, and they might have a chain for crossbows as well, whatever kind of assets they're trying to sell, right? So that state, whenever it's sold to Willy Coyote, includes the details of what is included in this transaction. In this case, he bought one catapult for a certain amount of dollars, and it has the signatures of the buyers and the sellers inside of it. As I mentioned before, all the code in Corda is JVM based. The example here is in Java, but you could use any kind of JVM kind of language. And that means that these are just plain Java objects, which is nice, because if you want to be able to integrate this into your backend system, you can just install Corda on a node, connect it to whatever you want using Java, which most people are familiar with, at least at some level. We do find that people who are not fans of Java, they tend to make an RPC call to whatever backend service they like to use. I'm a Node.js fan myself, so I just built a little gRPC bridge between those two, so you're not necessarily locked in there. So when that state arrives at Willy Coyote with the transaction that is already signed by Acme Corporation, it has to check to make sure that this is a valid transaction that it agrees to, right? In Corda speak, that means that there's a contract. And a contract does all the basic stuff that you would expect with a DLT application. It checks the transaction to make sure that it's legal according to the rules that are defined for this kind of network, and any other kind of business logic that you want to implement. For instance, you want to make sure that the price is a positive value and not a negative value. You might want to check weight restrictions for shipping. You might have something attached to the state that you communicated, like a document that has a proof of sales or a bill of lading, or if you've got a music service that you implemented on blockchain, there might be a song appended to it. The contract checks all of those things in the state that you've communicated and makes sure that everything checks out. Once that's done, it adds its own signature, sends it to the notary, saying both parties agree with this transaction. It checks out, it follows the rules of the contract. Can you please check to make sure that everything's valid and there's no double spend, etc. And if that's correct, then the transaction is final and it is committed to the ledgers of Wile E. Coyote and Acme Corporation. The final thing I will add to that is that, as I said, privacy is built in from the ground with Corda. Say that you have a bank account. Every time that you do a payment with your bank account, whether you go to Starbucks or you buy something on Amazon, you don't want that committed to a global ledger that everyone could see, right? So privacy is important in business applications. So Acme Corporation will have a ledger that shows all the transactions that it has done with all the different Looney Tunes, but Wile E. Coyote would only see the transactions that it has done with Acme and other parties. It would not have any insight on the other transactions that happen between different parties. The final concept that's important in Corda is what we call a flow. So as I said, Corda is not a global distributed ledger, and the parties are the only ones that actually can see the transaction. So there has to be something that builds that connection between the different nodes in the network. And the flow is the thing that implements that. And again, it's a plain old Java class. And it allows you to build a very opinionated implementation of how you believe transactions should happen on a network. For instance, do you require signature from the receiving party? There might be some situations where you don't. Or do you want to report every transaction to the IRS because you're a gambling site? In that case, you could build that in as well. Or there's a multitude of different kind of implementations that you might want to build. So the default you get whenever you download the sample web and you use that to develop is the basic transaction between two parties and a notary. But because the source code is there, you can very easily take that flow and start implementing any kind of solution that works for you. For instance, one of the things that we've seen before is that notary services by default do not see the contents of a transaction. They only see the two signatories between those two, and it uses that to prevent double spend. However, in some situations, you might want to have a verifying company that says if something is in stock or if something is legal or records your tax records or any kind of solution around that. And you can change that because all of these Java classes are very easy to edit, and you can add whatever opinionated implementation to that. So the final thing to keep in mind is that all these state transactions follow the UTXO model, which is basically you've got an input state which gets modified and discarded, and there's one or multiple output states that come out of that. So for instance, when Acme created these catapults, it created a new blockchain with the catapults amounts on there. When Wile E. Coyote bought one of those, it had that as input and it has two outputs. One of them is internally, I now have 2,047 catapults left. And the other output was the block for Wile E. Coyote. So that hopefully gives you a bit of a basic overview of how Corda works and how everything communicates with each other. The thing that I find is that especially people who come from an Ethereum or a Bitcoin kind of background is that they expect that there's this global network that you commit an application to and it just runs somewhere in this magic internet kind of cloud thing, right? Now that is not the case with Corda. With these kind of enterprise applications, you tend to run your own nodes which connect to other different nodes, so you need some kind of network. Now, R3, the company that created Corda, set up a foundation called the Corda Network Foundation, and that manages everything from signing up companies, checking their identities, issuing certificates and validating those certificates when you join that network. And it provides a notary pool as well. So if you're interested in that kind of a service, which in many cases would save you a lot of work of having to build it yourself, then I would highly recommend checking out Corda.network for a lot of information around that. If you're just getting started, however, that's a little bit heavy-handed because it does mean signing up for a yearly subscription, which costs about $100, paying about a cent per transaction. So if you just want to get your feet wet and get a bit of a feel of how it works, we also have a test network. Of course, test networks comes with no guarantees whatsoever. If you break it, you get to keep all the bits, and that's pretty much the only guarantee that we give you. But it does mean that if you just want to get up and running, you don't want to have to deal with building your network, you can just click the join test network, you get a certificate, and then you and other parties can join that network and communicate with each other. Finally, you can also go to the Corda documentation, which I highly recommend anyway, and we have a big section there on how to build your own network. And as I alluded to earlier, a network is pretty involved. It means that you need to have a root authority that issues certificates. You have to make sure that that is secure and not easily hackable. You have to have some kind of rules in place for who can join under what circumstances, how you would remove them, how you make sure that no abuse happens on that network. You'd have to initiate your own nodes pool as well in multiple locations and make sure that there's fault tolerance built in there. So that is heavy-handed. It is quite a bit of work. Of course, it is fully built in an open source version. So if you want to have nothing to do with R3, that is 100% possible. But generally speaking, we find that this is only the best solution for people who want to have no exposure whatsoever to the external world for their own internal transactions. If you're, say, building a big stock exchange and you don't want to have any leakage at all of what kind of transactions are happening there between parties, you might want to build your own network with your own notaries and your own door gatekeeper. Other than that, I would highly recommend just using the Corda network. It will make your life a lot easier. So finally, for anyone that's interested, these are the links to keep in mind. So the source code itself is on GitHub on the Corda. Our documentation is on docs.corda.net. We have a Slack channel that a lot of us keep an eye on, so that's a great place to reach us for any questions that you have. And of course, we check Slack overflow as well, and the Corda tag is something that we monitor there. So I figured it would be great to show the engineers here in the room a little bit like how do you actually build a Corda app. Florian is in town, so he's going to show you live how to build an application. Good luck, Florian.
Yeah, thanks. Yeah, so let's go and have a look how we would go about building a Corda app. Now, just gonna close all these. It's, as Chris mentioned, there are two, there are three concepts that are central to this. There are states that capture the shared facts that we put on the ledger. There are contracts that determine how these states can evolve. And finally, there are flows which we use for assembling our transaction and sending it around between parties. Now, we're going to create a very simple IOU app. And let's say I borrowed some money from Chris, and because we are both a bit forgetful sometimes, we want to keep track of how much money who borrowed from whom. So, $20, dude. So we just put this in a simple data class. We put the amount here. And now for this demo, we just use an int.
Zoom in the font size a little.
Oh, yeah. What was it? Command A.
Just pinch on the trackpad as well.
Increase font size. Oh, not enough. Okay, is this better?
So one of the things.
Oh yeah, I can just zoom in.
No, you've got a control which is different.
Yeah.
If you zoom out, then you can just do. Nope. No. Yeah. See?
Oh yeah. Cool. Thanks. Yeah, I don't usually use a Mac.
He had to use my computer today.
Yeah. So we put the value on there. Then we want to represent the borrower, and finally the lender. And so here the borrower might be me and the lender would be Chris. And to represent entities in the network, we use the party class. And that just consists of a simple X500 name and a public key. And then the last thing we need to do is our state has to implement the contract state interface. So, and this interface is quite simple. It just, all we need to do here is, all we need to do here is implement get participants. And the participants are the parties that get notified when something, when the state is created or updated in any way. And that's it. We defined our state. Now, onto the contract. This is also quite simple. We just implement the contract interface. And that requires us to implement the verify method. So again, I'm gonna zoom in a bit. And verify, here in verify we get a transaction. And if anything doesn't seem right with this transaction, we simply throw an illegal argument exception, and that's it. Now on this transaction object, we have a couple of things. So as Chris mentioned, we follow this UTXO model. So we can, for example, get the input states of this transaction. Input states. We do have access to the output states. And all that. And for example, when we create an IOU, in this case we would have no input states, and we would have one output state, our IOU state. So in this case, we would want to check that the input states are that there are actually no input states present. So we could say if input is not empty, throw illegal argument exception with some meaningful error message. Now, we would usually do a lot of more checks here, but maybe let's go on to flows. So okay. So here we have a flow which lets us create IOUs. And we have two sides here. We have the initiating side and the accepting side. So if I borrow money from Chris, then I would start this initiating flow. And then on Chris's Corda node, this acceptor would be invoked. And in order to write a flow, you simply extend this flow logic class. And that's an abstract class that has this call method that you need to implement. And that's basically where all the magic happens. Inside of flows, you have access to this service hub. So here, for example, we see how to get the identity of a notary from the network map. We can also get our own identity from this service hub. So we would say my info, the legal identities, and then first one we get. And then we can basically start by creating our IOU state. And in there we would pass in the value, ourselves as a borrower, and then the other party as the lender. Now, how to build a transaction? And to build a transaction, we use the transaction builder. And here we pass in the notary because every transaction needs to be associated with a notary. And then we can just take this transaction builder and add our state as an output. Add output state, IOU state. So with this transaction, we can go on and actually verify it to make sure that it's correct. So what we will do is, let's say transaction builder dot, transaction builder dot verify, and we pass in this service hub here. And now that we know that this transaction is valid, we can go ahead and sign it. Sign initial transaction, and we pass in the transaction builder. What we get back here is this transaction signed by us. So signed by us. And then the next thing we want to do is we want to send this transaction that was signed by us to our counterparty, so they can evaluate it and then sign it and send it back to us. So what we would use here is actually a subflow. So Corda provides all kinds of useful subflows that you can use for building your own flows. And the subflow we are using here will return a transaction that is signed by both parties. So actually what we do first is we get a session with our counterparty, and there we just pass in the other party. And then with this session, we can call a subflow, and we would use the collect signatures flow. And here we just pass in the transaction that was signed by us. And this session that we just created. Now the last thing that needs to happen once this transaction is signed by both parties is that we want to get it signed by the notary. So again, we do that by calling a subflow So this time the subflow we use is the finality flow. And again, we pass in the transaction that was signed by both parties and the session that we have with the other party. Okay, and then we just return this. Oh, and we're done, at least on this side. So what the finality flow does is it submits our transaction that was signed by both parties to the notary, and then also takes care of recording the signed transaction in our vault. The vault is Corda's abstraction over the nodes database. And then on the other side, we have this, we have the flow that we initiate. And this is similar to the one we just saw. We just extend flow logic. We override this call method. Here we implement our own signed transaction flow. So on this side, we can do some additional checks if we want to. Yeah, again, at the end, we just call this receive finality flow as a subflow. Yeah, and that's pretty much it. Yeah, so once we defined this state and contract and our flows, we can package this all up and turn it into into a jar file. And then once I have this jar file, I would sign it and distribute it to the people I want to interact with. Or I can just give them a link so they can download it, and then they would load this Corda up in their Corda nodes, and then they would be ready to transact with me. Now, for testing flows, Corda provides a lot of really useful utilities. So, for example, we have this mock network, which just simulates a Corda network, and we have these mock nodes that we can use. And then for testing, we can just kind of spin up a Corda network and put some nodes on it and let them load our Corda up and interact, which is really useful. Yeah, and that's basically it. So I think we have some time for Q&A. Yeah.
So who wants to go first? Who gets the honor? Any questions at all?
So you talked a little bit in the beginning about the test network. Is that, when you say mock node, is that related to the test network, or?
This test network is something different. It's a network you can sign up on these mock nodes. They're just you just spin up a local network on your laptop, and yeah. And there's a test network you can actually interact with other people who signed up to that. Yeah. Yes.
How do you? I didn't know. I'm just learning some of this myself. And your developer certification is actually very good. I still didn't totally get how you attach a document, like for legal purposes, and when you should do that, or why. Is that more determined by, the legal team, or I guess?
Yeah.
Okay, I guess I thought that might have been.
Hi there. So just to repeat the question for the recording, because we have a microphone here as well. The question was, like, if you want to attach things to a state, to a transaction, is that driven by technical requirements, legal requirements, or what? And basically, a state can be as little as an integer and a party A and a party B. That's all you need to be able to do a transaction. So that's the only technical requirement. However, it might be the case that sometimes you automatically generate legal documents, right? Because maybe the country you're doing business with has a requirement, or you want to have a human readable copy of the transaction that you can give to your lawyers. So if there are any kind of business motivations why you would need an attachment to the state, then we have an API where you can just attach any kind of binary object to that transaction. Okay. Cool.
I missed that. Thank you.
Do you have any deployment tool to deploy the code for each individual participant code node?
So the question is, do we have any tools for deploying applications to a network? And the answer to that is email. Sorry, that's a joking reference. Anyway, so basically, because you're running your own network with a lot of different parties in sort of a consortium or agreement with each other, it is an agreement between those different parties to run the same code. And we don't offer a tool for deploying applications to the network. However, it is relatively simple to build because an application is a jar file. So you could very easily rsync that or send it for SSH or send someone an email. Typically, we find that when these kind of institutions want to do business with each other, multiple banks or IoT companies, they agree to build the application together. They pool their resources so that they all contribute to that one single application. And that developer team then also makes sure that every party runs that application.
Okay, like if we are a network operator, we have a group of companies who, some of company may not have the technical resources, then we as the consortium operator will have to provide the technical services to help them to deploy the code to their node.
Yeah, absolutely. So the question is like, if you've got customers, if you're a system integrator or a network operator who do not have the technical capabilities, how do you solve that situation? Oh, Richard, you sound like you want to answer this very eagerly. By the way, this is Richard. He's with R3 as well.
Thanks, Chris. Just one, it's not part of the platform, but just to add to what Chris said, there is actually a sample in our solutions repo called the Corda distribution service, which is something sample code you can use and deploy to all your customers that allows apps to be pushed out if you want. Obviously, there's a security implication though with just pushing apps onto people's nodes. So if you're managing a consortium, as it sounds like you are, that might be useful to you. But we don't ship it as part of the product because there are certain cases where you wouldn't want to be pushing stuff out without the node operator actually approving. But look for Corda distribution service. Just Google it. It's there.
Yeah, and the other thing that I will add to that is that if you're a service company who's providing these kind of services for companies that do not have the technical capability itself, you would probably be running these nodes for them, right? You would do your own Corda implementation, then charge them a fee to host that for you, in which case you can implement any kind of solution you want to.
Okay, have just one more question.
Yeah, sure.
We'll
get to you next.
Right, so when we are going to deploy the application, and then we have some concern of the participants node 1 to node 10, and then the data is running on each of their nodes. So what if there's any problem that happened that one node gets wiped out? What would be the backup situation that we can have, whether we can build it into the network or build it into the application itself, so that we can make sure that any such events that happen that they are not going to lose the data.
So there are multiple solutions to that. I have a software engineering background myself, so I'm going to answer it from that perspective. When you implement a node, you have a database backend connected to that where it records all the information that happened in those transactions. So it ships with a default database, which is called H2, which is a Java thing, but you can connect it to MySQL or Azure database or Postgres or Oracle, any kind of database that an enterprise uses at the moment. And of course, those kind of databases already come with backup and restore solutions. So even if you wipe out a node, as long as you have a live copy of your database somewhere, you're not losing any data per se. Now say that the worst happens and you've got a customer that puts their database in one data center as well as the node, and there's a natural disaster that wipes it out and they don't have any offsite backups. Well, first of all, never do business with them again because they're terrible at IT. But second of all, the nodes that you've done transactions with also have a copy of that ledger. And because they're digital signatures on those, you can verify that those are all valid transactions. So you could recreate the world order based on the knowledge of other people in that network.
You mean out from like the Oracle or the transaction builder or somewhere?
The people that you've done transactions with, they will also have copies of those transactions.
Well, but that record is leader to node basis. So that
Exactly. So you'd have to go to all different parties and get copies from them. There's not one. Exactly. But again, that would not happen because any capable IT team will make sure that you have a distributed database with an offsite backup. So if the worst happens, you should just be able to restore that backup and be up and running again. So this is really an extreme hypothetical situation where you'd actually have to reconstruct the entire transaction chain again. Yeah?
It might make sense that you guys can go into such capability going forward of that sort of recovery.
Yeah. Well, database recovery is something that's existed for decades, so there's really good solutions for that.
Network recovery is basically blockchain network recovery.
Yeah. Well, what I'm saying is, generally speaking, you don't need network recovery because the database recovery exists. And it would be a really weird case of unfortunate incidents that you would have to go a step beyond that. But it is possible, absolutely. Cool. You had a question down there as well?
Yeah. What happens when there's some kind of version mismatch between multiple parties and you create some kind of incompatibility between those flows? What happens?
That gets complicated. Like theoretically, that should not happen. But generally speaking, there are a couple solutions built in. Like for instance, if there's a flow initiated or a transaction, if you will, and it sees that there's an old version, it can pause that and wait for the right version to come online. You could also try to implement backward compatibility with new versions when you write that application. If none of those situations are true, then that transaction is just pending until that party upgrades their application.
By default?
Yeah, by default, it will just wait for it to come online with the correct version. So there's something in that flow concept where it hibernates any flow that it cannot currently complete. And sometimes that is as simple as you initiated a transaction that requires a human being to do something in an order system or go to a warehouse or whatever before they click the button, complete this order. So the whole system is based on the fact that flows can be written to disk, where they hibernate, they wait until they can be resumed again and start communicating with each other. So something terrible happens, like a network outage or a version mismatch or any other kind of disaster that happens, those flows will be hibernated, written to disk, and then rehydrated again when they're ready to continue.
But suppose that I have a version of this code that doesn't require human intervention, and I have a new version that requires a human intervention.
Yeah.
What happens when those two versions communicate with each other? What is the
So the code that you saw Florian type earlier, I don't know if you went through that, but in that flow, there's like, hey, sign a transaction and wait for the counter signature. So that just pauses. And your code isn't even aware of the fact that it was pausing at that time. Because all it's doing is waiting for the counter signature from the other end. And beneath the hood, Corda takes care of all those details for you. So you can just code it as if everything's just happening instantly, but it doesn't necessarily have to.
So on that, for the calling code, the code which is calling it, at what point does that get returned? Because the code flow would stop at several points in that code that you had.
Yeah.
So at what point does the calling code return, in fact?
So
and what does it get in return, in fact? Does it get a sort of acknowledgement ID in fact?
there is an ID assigned to every transaction, but basically every transaction has multiple steps. The first one is, I'm going to create a transaction, I'm going to create a state, which could either be empty or have some stuff in it that I want to transact already. I'm going to send it over, then I'm going to wait for a reply, and that already could pause or not. And maybe I need to send that to some other people as well, like tax institutions or banks or other systems that I'm connected to, or do something in Salesforce. And when that returns, then I'm going to send it to the notary service to get it signed. And only when that returns and that notary signature is communicated to both parties, that's when a transaction is final. So all the way up to that point, it's in progress. But when you have the final transaction with the signature of the notary, that's where you go, okay, we're committed, everything's done. Now I can do whatever follow-up action I need to take.
No, what I was asking that, let's say there is a method which is initiated by RPC. So when I make the RPC call, what do I, because it would not wait for all these steps to complete, in fact, it would have return immediately at that point. So I was just wondering, in that flow, when does it return, in fact? Is there anything executed before that call returns? Is that
So that whole function is executed step by step.
yeah, step by step.
But every time it waits for the thing that you asked for it to do. So it's up to you to define where it passes and where it doesn't.
But the first call is the synchronous call. What I'm saying that there are two parts. The first call is the synchronous call. These things are happening asynchronously. They're pausing.
Well, even the first, the first call is that we apply our own signature as the party that initiates, which of course does the contract validation as well. Then the next step is sending it to the other party.
And at that point it would pause. In fact.
Yes, correct.
At that point it would pause. So what I was asking that, my initial call that I had made, in fact, at what point does it return, in fact? And does it return, and at that point, does it give me any ID or not?
Yes, it does. So it sends it to the other party. That other party checks the transaction, executes the contract on it, does whatever magic it needs to do. That returns a state to you. Now, that state at that moment will have two signatures on it and all the suggested stuff. And that is returned to you, but it's not final yet, because it's not final until you take that bit of information and send it to a notary.
And I have another question, in fact.
Yes, sure.
So can a node have multiple legal identities, or it has only one legal identity?
At the moment, it only has one identity, but we're working on supporting things like accounts on a node, in which case it would have multiple legal identities.
So those
that will be part of
are
version 5.
So accounts are sub-accounts, or these can be independent parties? So independent parties can be sharing the same node, or
so those
or
are
that be under one party there are different accounts?
That will be sub-accounts.
Sub-accounts.
Yeah. But a node is pretty lightweight. Like one of the interesting companies we're working with is a car manufacturer. And one of the things that happens with cars, and I'm not a driver myself, but I've been told, is that stuff breaks down and it has to get fixed. So you go to a mechanic and there's a little booklet, at least that's how it works in Europe, I've been told, where the mechanic writes down what happens, he puts a stamp on it, and that becomes the transaction log of everything that happened to your car. Of course, you can rip out pages, you can fake a stamp. There's all these nasty things that make that less than 100% reliable. So they're actually going to run a Corda node inside of the car to track all these transactions with all the cryptography signatures, making that a dependable source of truth. So if you can run it in a car and a little CPU, then running a node on your big server is probably not an issue. Cool. Anyone else have any questions?
When's your next CordaCon?
It is in October,
US.
yes.
In London again?
Yeah.
That's where the engineers are, so you get all the engineers.
Cool. Back there.
Yes, my question is Corda, are there specific use cases that Corda is best known for, or is it a general?
So that, to me, is a question that has multiple facets, because Corda is currently well known for working incredibly well with financial institutions. We're working with a digital stock exchange in Switzerland. We got whole banking consortiums transacting with each other. Finance is kind of the thing that we're known for, but I kind of find that a shortcoming because you can do so much more with Corda. So we've got IoT companies, logistic companies, energy companies that trade green energy with each other. There's a large amount of use cases that you can do with it. Like one of my pet projects is that I'm building a game that is inspired by Ready Player One. Have you guys seen a movie or read the book? A few people here have, but the basic concept is it's this dystopian future where everything is terrible, so everyone logs into this virtual reality world where things are pretty okay, right? And this huge virtual reality world that all these people on planet Earth are connected to is shared between all of those. And there's multiple companies that plug into that to provide experiences, whether that's education or a Star Wars experience or whatever kind of stuff, right? Now that means that you need to have mutual distrusting nodes that provide game experiences that can exchange things like credits or items, all that, those kind of things, right? Now to me, that is DLT, that is a distributed ledger. So I'm taking a little sample web from a gaming platform startup, empowering that experience with Corda to make this interoperability nodes connecting to each other in this game world. And it works perfectly for that as well. So to answer your question, we're best known for finance, but please don't let that limit you. Okay. Thanks for the question. Anyone else? We're on a roll here. We still have a few minutes left. Oh, back there?
I may have missed this earlier, but how many transactions per second can you, I know it's dependent on the size of data you're writing.
Yeah, exactly. It depends on network size, back-end connections. To give you an example, the use case that I really enjoyed is that at some point, one of our system integrators took all of the transaction data from the New York Stock Exchange for a day and replayed that over a Corda network, and they finished that within 4 hours. So it can power the largest stock exchanges on the planet without having to have too much scalable hardware in place. I don't have an exact number for you though, but it's really fast.
Well, oh, sorry, just one
on.
thing. One thing we can mention with regards to that. So we do publish the numbers, the transaction per second.
What is it?
I don't remember. I'm not good with numbers. But before Corda 4, you kind of had to trust us on those. But with Corda 4, we actually have released the tooling that we use internally to do performance testing. So people can actually go and set up their own load tests and verify for themselves that they actually get the same numbers that we claim to achieve.
So Richard, do you have any recollection at all?
Yeah, so the example you gave was the TTCC project. So that was across the Corda network. It was 115 million US equity trades in 5 hours. It mapped down to 20,000 Corda transactions per second across the network.
That's decent.
And the most recent Corda release of the commercial distribution, I think for cash issue, we're north of 1,000 TPS. So I'm not aware of any use cases that Corda can't scale to.
And in that, in that particular use case, how many Corda nodes were there?
I need to check. So there were a lot. It was we had to, because there's a whole decentralization. We had to model every dealer and every broker in the United States equity market. So there were hundreds of nodes. Not all of them very busy. Some of them were very busy. Some of them were modeling quite a complex scenario.
Still, 20,000 transactions per second is a nice number. Yeah.
So you mentioned that we're able to download the distribution services. Are we also able to download integration, testing, all that type of services?
Richard would know better than me.
The link was there, github.com/Corda. There's a solutions repository with the Corda distribution service. There's actually a ledger sync service to partially answer your question earlier, and a whole bunch of test tools. Everything Florian showed you, all the unit tests, the mock network, all of that is just there out of the box.
Are those developed by R3 or by the community?
A little bit of both, mostly by R3 at the moment, but we do have a bunch of contributions from the various banks and integrators that we work with.
Yeah, there was one more question in the back.
Does Corda provide anything for the fault tolerance on the transaction level?
For what?
For transaction level, at transaction level, or second on the network level. So, or we just, as a developer, we had to implement some kind of fail-safe mechanism for that. Or does Corda provide anything?
So we provide all the bits that you don't have to worry about how DLTs work. From there on, it's completely up to you. So we basically talk about states and contracts and flows. Those are all classes you can modify in any way that you want to. So if you have a contract that needs to check a backend system to make sure that something's okay, that's fine. If you want to integrate something with a status in Salesforce where it says deal initiating, deal being negotiated, deal finalized, you will put that in the flow, and at every different checkpoint you would update that in your backend system. So it's quite flexible, and in fact it goes so far that if you want to change things like the consensus algorithms or the way that stuff is hibernated to disk, or all those things are pluggable Java classes. So in those 3 basic classes, you can do 99% of the stuff that you might already want to do. In that 1% case where you want to do something hyper-specific and different, we have a pluggable architecture for that as well. Cool. Well, I think we're out of time, so thank you all so much for the great questions and your attention. You guys have a good day.